So, good morning, good evening, everyone. Welcome to today's session. So, today we are going to delve into the world of object-oriented programming. So, I know some of you are familiar with procedural, and maybe some of you are familiar with OOP, those that have experience with Java, C++, C Sharp, and maybe other stuffs like that are already familiar with object-oriented programming. So as opposed to procedural, OOP has some pillars that make it more that has more advantage over or advantages over procedural programming. Those pillars we cover some, maybe though we didn't use the term abstraction, but we've covered that yesterday while we organize our code into module and we hide some of the complexities in our code by just providing a function name to the user so that the user can use just the function. So in today's session, we are going to discuss more about OOP. So what OOP does is OOP consider the real world objects. In other words, it sees things as objects. You know, Internet of Things, whereby we have things, everything is things. So in OOP, we consider everything as object. So consider yourself as object, consider this lesson as object, consider the program you are currently running as object, your computer is object, and stops like that. So this is what OOP sees. It sees everything as object, and these objects are related to one another in one form or the other. And so let us just go in detail. So by the end of this class, every one of you will write class by himself. You are going to write a class by yourself, and maybe you will create an instance of a class. So you can create as many instances of a class. We will see in detail what I mean by that. And you will specify a kind of information that can be stored in instances that you have created, and you will define action that can be taken by these instances. In other words, the function that they will do. Then you write classes that extends functionalities from existing class, because sometimes we don't usually start from scratch. We can just grab some information from somewhere, then we build upon that. Just like in this class, you already are familiar. You are already familiar with some stuffs. Maybe you know the grammar of English. That's why you are understanding. So you are just taking some things that you already know, maybe all from somewhere, then you use it here. Then you will store your classes in module, because you already know how to create module. It's just a file name with .py extension. Then you keep on writing your code in a file, in that file, so that you can use it later. So what is OOP? And OOP is one of the most effective approach to writing software because it allows modularity. You can write, we discussed module yesterday, so someone can take this kind of module while this one has his own module. This one has, just like the system we have, you are a system on your own, because we have this digestive system, you have the respiratory system, you have this. So you can just write your code in different module, then you can just combine the module to create a complex system. So in object-oriented programming, you write classes that represent the real world, as I said, the real world situation, and you will create objects based on these classes you have already defined. Just like you define a function, then you use the function. So you can create classes, you can define classes, then you create object based on the classes. There are many advantages of using classes in OOP, but let's go and maybe discuss this example. When you are in primary school, you were having fun with cardboard paper. Yes, whereby when you see an image of something that you want to imitate, you just take that image, then you maybe trace. So tracing on a paper, maybe blank paper, you can have as many copies as you can of that object. Maybe you saw a beautiful flower that you want to copy, then you can use that template of the flower, then you can create as many flowers as you can using the paper. Yes, yes, we had fun using that. So the same thing applies to object-oriented programming. What do we do? Because we say we consider everything as object, so we can consider a dog, for example, as an object. Yes, so the object has some properties, just like this one. So look at this. Let's say we have this dog on the left, which I call base class. So we have this object that you want to create many dogs from this template, because a class serves as template for objects. Yes. So from these templates we have that you can trace, we can create as many objects as we can based on this. Remember, when we trace this image that we can see, or this figure on the left, they will share the properties with all of these objects. You will have they will have the same size, same height, same structure, same eyes, same ears, same tail. Yes, because they are created based on this template. So consider this as a class, this template, and then consider those objects created based on this class as objects. So this is what object-oriented is in short, in layman language. So each instance created from the dog class, as you see here. So we have the dog class here. So each instance created from this dog class will store a name, because this dog has its name as well as age, maybe date of birth, maybe color, color of eye color, maybe breed, and many other things. Maybe the hair,
Height.
the height, yes, and many other things, and many other properties. And the dog also has some abilities. Maybe the dog can sit and can roll over. So that's why we have this diagram. So this dog is sitting because we know that the dog sit to perform some kind of action. So the dog can bark. Yes. The dog can run. All of these are actions. So when we have some attributes, so we use this like name, like age, like color, like breed, but the action, we make them to be in verb form like this, and we put this opening and bracket so that we can have a function. So as some of you might be aware, whenever we write code, we don't just write codes like that. Imagine you are going to write a very useful application. Maybe you are going to write an application for banks, or you are going to write an application, maybe a portal for a particular university. You don't just start coding like that. You have to make a design of your program. You have to have a design. Just like when building a house, you need to have a design of that house before you built the house. So in programming, we can just code like that, start writing our code so that we can come back and keep modifying our code. No, we need to design our code. So when designing, we need to consider, especially when we are designing based on OOP, so we need to design our objects just like this, similar to this. So we have this as as a class. So this is a class. So we write the name of the class just like this. Then we have these properties. We can have as many properties as we can. Forget about this plus and minus. We will talk about it later when we come to some of you who are familiar with Java already know about this. So the properties, we write them here. Then we have the function or the action performed by the docs. We write them here. So here are functions. If you remember, whenever we have this and this represent function. So here the properties or attributes of that class. So we represent the data types here. It can be anything. So how do we represent or create class in Python? So to create class, this is what we do. We write class. Class is a keyword. So here we are telling Python that, please, can you create a class for us? Just like the other programming language, when you want to declare a variable, you start with a data type. So here we start with the keyword class. So here you are telling the Python, please, I want to declare a class. Then after the keyword class, then you write the name of your class. Remember, the naming convention also applies here. You can't just write doc and put space here. No, it won't work like this. So you have to use, we don't need space. And it is advisable to capitalize the first word whenever you want to create a class. It is not necessary, but it is a good habit. It is good. It is convention to start with the capital later. And when writing your function, you use lowercase. So this is how we create class. We start with this, the keyword class, then we write the name of the class, then we write colon, then we press enter. When you press enter, your IDE may automatically indent. So if you are using maybe Notepad, so it may not be indented. So you have to use tab to indent so that you can have like 4 characters after the left margin. So when you write this, so you are defining your class. Then inside your class, then you start with a function. This function is special function. If you are familiar with the other programming, you know constructor. If you program in Java, you know constructor. When you want to create an object in Java, what you do, you write the class name, yes? You write the class name, then you write the object name that you want to create. Maybe you want to create a dog or my dog, for example. Let's say I want to create my dog. Then you put assignment operator, then you put the keyword new, then the next thing is the class constructor. Because in other programming languages, the name of the constructor is the same as the name of the class. So by default, you have a constructor without anything, without any parameter. That's by default. So, but you can overwrite this. We will learn about this. Those who are familiar with Java or C Sharp, they know this when creating objects. So this method constructor is the same thing as this one, init method. So whenever you create a class, don't forget to create your constructor method. That's init method. So init methods start with double underscore here. Then you write init, then you post append it with double underscore, just like this. So you have double underscore, then we have init, then we have double underscore. Then you open your bracket. So if your class accept parameters, so you put them here, but you need to supply this special parameter called self in OOP. In the method that we use to define, we don't need this self, and it will work perfectly. But in OOP, you are required to provide this. Even if the function or method, yes, so now it's OOP, I will use method instead of function. When I say function, I mean method. When I say method, I mean function. But in object-oriented programming, we refer function as methods. Yes, whether the method returns value or it doesn't, we just call it method. So here, when creating objects, what this means, whenever we want to create object of this class, we need to provide two parameters here. The parameters are name and age. Then here, the next, that's line 5, says when the user call to create an object of this class, please assign the value provided by the user to this name. So later we will talk about class variable. Yes. So here, this name will be assigned to this and this age to this. What does this mean? Why are we using SEP? Those who are familiar with other programmings, I keep saying this, are familiar with this keyword in Java or this in even PHP. We use, instead of using dot notation, but we use a dash and this arrow. Yes, remember. So we use this, we write $sign, then we write this, then we put this, then we put whatever value we want to assign. This is what we do in PHP, and in Java we use this dot, the property, then we assign whatever we want. So the reason we are doing this, we are letting this variable to be accessed from anywhere in this class. That's the meaning. When we do this, it means that this variable can be accessed from any function in this class. So when we want to access it, we can just use sep.name to access it. When we want to access it here, we can use sep.name or sep.age to access these properties. So I keep saying properties, so the properties and variable refers to the same thing here. So that is for here. Remember what we said, we need this self whenever you are creating a function, when you are doing OOP, we need this plus the other parameters if we need them. If we don't need them, you can just write to yourself and close your method. So then we have another method called set. Look at our diagram. We say that doc performs some action. So if you have other actions that docs do, then you can put them here. you can put them here. You can put as many actions as you can here. So for this action, we create a method for each action. For the properties, so we can assign them by default here. So whenever we are creating an object of this class, by default, the object will have this kind of properties. Then we have rollover is another action. Then you see we have save. Therefore, whenever you want to call this function, you don't need to supply any variable. So this is very good example. So let us run this. So when we run it, now we already have a class. Remember, it's just like this class we have. So we have this class. So we can create as many objects as we can. We can create n number of objects. That's it. We can create n number of objects. You can create 1, 2, 3, 4, 5, 99, 100, 1 million, whatever. So how is this useful? This can be very useful when you are creating a very complex application. Later, you will learn about what we call generalization and maybe specialization when you have some properties that is shared between others, while there are some peculiar things that are not shared with some. So we can divide our classes into number of classes so that we can inherit from other classes. So now what we are going to do, we are going to create an instance of that class. Since we create a template, consider this as a template with which you can create as many objects as you want. Just like this one, this template, you can create as many objects here. You can put the color here. You can put yellow for this dog. You can put blue for this one. You can put black for this one. You can put maybe red for this one. You can put any color. We have number of colors, thousands of colors. So you can put any color, which means from this template, you can create as many objects as you can. So now we have a template class here, which is this one. So what we are going to do now, we are going to create an object from this class, an instant from this class. So to create an object, look at it. You just need to create a variable. So this variable is your object name. Is your object name. So if your dog is called Bush, so you can put Bush, then you create the dog. Yeah, or you can call it my dog. You can call it object one or dog one, whatever. You can just give it any name. Yeah, this is just a variable name. So because we have a property name, remember our init function. We have name, we have age. So when creating the object, we need to supply the name of that dog as well as the age of the dog so that we can use this. You can use the name or we can use the age. So when we run this, we have already created an object. Now this is instance of that class. So let me do something. Let me write this type and put my dog. So look at what we have. You see this, which means this object is of class dog, and we can create my dog one, my dog two, my dog three. All of them will share these properties. We'll share a name, we'll have name, and we'll have age, and we'll have this function. So any object.
I have a question.
Yes.
So, based on your own explanation, it means the name and age, they are constant variables, or let me say objects that we will be using when making our class.
I don't understand. Can you repeat your question?
So, for example, now, since you said if we are to define our variable,
If
my
we are
dog,
to
we
define
write
our
the name of
class, to create an instance of a class,
yes, yes, create an instance, sorry. We
mhm,
are to write the name and also age. So, and based on your previous explanation, where you said we are to like here, just if we are to define our function, we
mhm.
write define double underscore init double underscore in bracket self, comma name, comma age. So that means this name, comma age, we are going to use it based on the task that we will be doing.
Yes, 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 it's true based on the tax. So the tax here is just uh maybe let me give you another example. Let's say you create a class called account. So you
Okay.
sometimes when creating an account, when you go to maybe your bank, maybe First Bank, they will say that you need an initial deposit. Yes. So in that case, whenever you want to create account, maybe you have a class called account. So there must be a variable here, maybe called balance. So you should have, when you give them money, they will put it in your account. So you have that initial, you will have set.balance, then you have that amount. So they will charge you maybe 1,000 naira. So whenever they want to create account for you, they will write maybe savings, yes, or maybe they will just create maybe they will give any name, they will say maybe account, then they may call it savings. For example, maybe you are creating a saving account, then they will write the money. Maybe you are providing, they are charging you 1,500. Then they may charge you this amount. So which means whenever you want to create an account for someone, you have to supply this. This one, you have to give this kind of money. They will charge you this kind of money. And you will see the money in your account. So it's similar to this. Whenever you want to create a dog here, you need to give that dog a name. Because I can't just create a dog without a name. This is the meaning here. I can't just create a dog without an age. Maybe it is this application is part of maybe uh, an application that will be used by veterinary uh, maybe hospital for animals. So they need to know the name of the animal so that they can use it later. They need to know the age of that animal so that they will know in advance how many grams or milligrams of drugs can be given to the animal. So that's the meaning of this. Whenever you want to create a dog class, so you need to supply a name, you need to supply an age. You get it?
Yes, sir, I understand, sir. Thank you very much.
Yes.
Hello, sir. Can you hear me?
Yes.
Yeah, I was raising my hand initially. I guess you didn't say. So there was this part you were checking, you were doing when you had to put self in the properties of a function inside a class. I don't know if you could scroll down there, sir.
Okay, I should scroll like this.
Exactly. So you were saying when you're trying to declare a variable,
Mhm.
you have to use self dot the name of the variable. That's only when every part of the class would have access to the variable. So I want to ask, is it possible that even the variable you've created from the first, which is name, you mean you can use it in another function like rollover? You won't be able to have access to the name without putting self.
Yes, we can protect. We have what we call access specifiers. Maybe when we reach there, I use it here, but I didn't explain it. This one is made public, and we can make it. In OOP we have the pillars of OOP. We can hide things from others, so we can do that as well, whereby we can hide something from others so that they can't use it. Yes.
So I'm not getting it, sir. What I'm saying is the use of self when you were making a variable name and age in the initial, making the function initial, the use
Yes.
of self name and self.age. Why can't we go ahead just use the name and the age?
No. It's you can't use that because it will not be accessible to others. I think we didn't discuss about when defining functions. We didn't maybe we have forgotten to discuss about local variable and global variable. So global variable is a variable that is accessible everywhere in your program, while the local one is just like this one. Uh, when you create a function, yesterday, as if you could remember, we create many functions. So when you create a function, those variable inside a function are not actually declared. They are declared when you call the function. When you call the function, that's why a variable declared inside a function are local, except you use a special keyword like global. Those who are familiar with other languages, even PHP, if you are familiar with that, you know the use of that keyword called global. If you are familiar with JavaScript, you know the keyword global. Uh, but other programming
Yeah.
languages are not like that. Some are like C, you need to define in advance in your header file that this variable is going to be global. Or
Uh,
is if it is not if not, it is just a local variable. So this is a must if you want to access this variable. So you need to use self so that it can be accessed anywhere in your
So,
program.
so, so are you saying using the term self, the prefix self, dot makes it a global variable?
Yes. So which means these are the default,
So,
just like the default values when you create this, so it will be assigned to this, meaning you can just use SEP to access this variable. That is
all right. My question is, why can't we just put it just below the comment, the variable, instead of having to define it inside the def function? Is it possible we create it just at the indent level of the def itself, so that it becomes in line with
here,
the functions?
here like this.
No, not there, not there.
Where?
Above it, above def.
Oh, above it here, above the
No, just
definition.
below, sir. Come down,
Okay, where?
come down. No,
Here?
come just after the axe. After the axe.
Okay, after the axe here. Yes.
Yes. Can
Forget
you
about
create it
this
under
line, tab 9. So we create it.
like
So you are familiar with PHP and other languages. This is what we do to make it global variable. So if you are
yeah.
familiar with Java, this is what we do. We just after the class, then we create our variables here. So this one I created by default. So they are not like this, a variable that you can create here. This one I created by default whenever you create an object or an instance of that class.
Okay.
Yes. So this is the convention.
All right.
So what this mean? It means this variable belongs to the class. So whenever you create an object, it belongs to that. So this one I created by default. It's not uh, a variable that you can create here. That's the meaning. Mm.
Okay.
We will
Thank you.
discuss in detail about that when we come to maybe when we go div. I don't want to move div. That's why I break the class into two, because there are so many things that we can do. I don't want to go into details about this. Let's just start bit by bit, then we will build maybe we will build a very complex application Yes, Idris.
Assalamu alaikum. Can you hear me?
Wa alaikum salam.
Okay, yeah, I think just to shed more light on some of the questions that were asked. Um, you can define a global variable, and I think the component will reach uh, that stage. But the idea here is if you are, as Falolo has been mentioning, familiar with other programming languages, you know the idea of constructor. So init here is a constructor in which you can initiate the variables or the names of the variables while creating the object. So as he said here, if you have my dog is equal to dog,
Yeah,
and you initiate the name.
Can you mute yourself, please? Yes, doctor.
Okay, so
Thanks.
you initiate the name and the age. So it's just similar to if you develop a website or maybe you are tasked with creating a school portal or whatever. Whenever you are registering either a course or a student or whatever, you are expected to register the person with his name, the date of birth, and the rest. You cannot create a person without a name. So most of those values that you put in while creating are distinct. So if you are creating a dog, it's expected that the dog should have a name and an age. If you are creating a student, the person should have a date of birth, their name, maybe their address, if you want to create it as an attribute of that person. Or else, if you're familiar with databases, there are several ways of doing that. So that's this. And also the use of the keyword self is, I think, more of a convention. So you can use any other word. So here you use self, you can use whatever word that you like. Just that wherever you are mentioning where you use self here, you should mention that same word. So you can use even your name if you like. So your name, comma age, comma name, comma whatever. So it will be your name dot name is equal to. So it's a convention. It's easier for you to remember because self uh, stands here, and I think it's much more explicit to you to understand. Self means an object of that class. So you are initiating an instance of that class. So self dot whatever. So it's just to shed more light. My question, Dr. Falalu, is can you have like default? Can you create an an instance of a class with default variables? My example: if you have def in itself, can you have name equal to a default name and then age equal to a default name so that you can create the object without specifying the name and the age, and then afterwards you can now edit the name or the age. I think I put the question in the chat. Yeah, thank you.
Yes, I think we have already treated that. So when defining parameters, so we say that when calling a function, you can call it with keyword parameters, the keyword parameters, and we can have what the term. So there are there are default parameters that you can define. So when you want to define a parameter, what you just need to do, or when you want to define a default parameters, what you just need to do is to use an equal sign there. You put the equal sign, then you put the values, and we say that by convention, when using default value, you need to give the assignment operator, you don't need to put space between the assignment operator and the value. So what you just need to do, you just provide the values here. Then here, you need to provide the values that you want. So in that case, you don't need to provide parameters when creating the class, when creating the object, sorry.
Okay, so thank you. So when you do that, sorry for, yeah. So when you do that, you can create a default object and create multiple default objects. What they will have is they will always have the same name and the same age, if
Yes,
you like.
exactly.
And then
When you
afterwards, then you can edit the name and the age.
yes, yes,
Because if you did not provide the default, so whenever you create an object and you did not specify the name and the age, it will present that, yeah, this is an error, you are expected to provide that. But if you have a default, you can continue creating and then editing afterwards. But if there is no default, you have to provide the initial variables. Thank you, Doctor.
yes, yes. Thank you for your contribution. So in that case, what the doctor is saying, if we have the default values here, maybe you need to define another function or method, let me say method, that can change the name. Because if you don't provide any uh, value or argument when creating an instance of the class, it means that any object will have the same name because you have the same default name. If you are using this, maybe this function or this class like savings, maybe whenever you want to create an account without saying the kind of account you want to create, maybe it will by default it will just create a savings account. So you can do that as well. Thank you for your contribution, Doctor. So let's. Is there any other questions before we proceed?
So, sir,
Yes.
my question again is, so now what doctor mentioned, is it we need to like define or let me say specify what the name is and what the age is before running the entire command or what?
Yes, for this one, when you want to create an object of this class, you need to provide the name as well as the age. Because our dog has these properties. If you decided to add additional properties, maybe you need to maybe let's say we have self, maybe let's call it self dot is backing, for example. So the dog doesn't bark. So you can just assign it like this. So you don't need to provide this one because this one will be assigned to this by default. So maybe you can change it later when you maybe understand that the dog barks. You understand?
Okay.
So you don't need to provide this is barking because we don't provide it here. We don't write it here. So you can just go ahead and use this one and this one.
Okay, okay, I understand.
Yes, so if
So,
you
sir,
have default one, as Dr. Idris says, if you have default name, for example, you are creating an app for supermarket, so you don't need to, because supermarket is busy, you don't need to uh, give a room to create a customer with unique names. You can just give a default name. So whenever a customer comes, you can have maybe customer. We can just call him customer. You don't need to identify who the customer is because we don't need it. It will not be very important. So you can provide a default value here. So you can just go ahead and create the object of that class without giving uh, a name so that you can make this optional when creating the object. If you need it, you can provide it. If you don't have it, you can just go ahead and create the object.
okay. Mm. So, sir, but I can see that like after running this thing, it doesn't print anything. So why is it that?
That's just like function. When we create a function, our function doesn't create anything. It doesn't do anything. We are just defining it. So when you want to use it, then you can just call the function. Remember, yes, when we define a function, when we run it, it doesn't do anything. It will just invoke, even if there are many codes, then all the codes will run up to button, right, left.
Please, mute your mic, please. Please. You are disturbing us.
Hidayah, please.
Yeah. So I have forgotten what I was saying.
So, like,
Doctor,
sir,
you
you
can
are explaining you are explaining just like function.
Yes, like function. So the code runs top to bottom, right to left. So when it encounters function, it will just run the function, but without doing anything. It's just leave it as it is. It will not invoke anything until you call the function. So let's say we have this.
Okay.
So when we run this, so let me comment this. So when we run this, you see nothing will happen until who is Hidayah? Hidayah is messing up our screen.
Maybe she's doing something different.
So let me kill in what. Yeah, I think that's all.
Dr. Faloli, you can make another person a co-host so that they can manage muting and unmuting others.
Pardon, Doctor, what did you say?
I said you can make another person a co-host so that they can manage muting and unmuting.
Yes,
and
exactly. So let us see this. Sorry. So look at this. I missed my screen as well. So when we run this, so you see we have the class. So if you didn't run this and you call this, you will get an error. So this is where what will happen here. We have our variable here. That's the instance of this class. So we are creating an instance of this class. So we are requested to provide these values because in our init function we have this and we have this. So when you call this dog, you are just like calling the constructor here. And as we said, in object programming languages, we have the class and we have constructor. So, and constructor has the same name with the class name. So this value really will be transferred to this variable name. And this 6 will be transferred to this variable age. So whenever we want to ask for the name, then we can just go ahead and use the object to ask for the name. For example, here, we give the name here, we give the age here. So we can access any attribute or properties of that object. How do we do that? To access the properties, we use the dot notation, just like what we do in Java. So we just use this dot. So we have the object, then we have dot. So remember, this one is the attribute. So we don't need opening and closing bracket because it's not function. So if you're accessing the attributes, the properties, just like maybe the dog is black. So if we have color, then we can use our instance name dot. So this refers to the object of that class. So we use the object name dot the property. So this one will give us the name of that dog we have created. So we can create as many dogs as we can. So when we do this, when we run this, this is what happens. It tells us about the name of that dog. If you are looking for age, we just need to do this. Then we get the age. So this is how to access any attribute of that belongs to that inside of the class you have created. Any question on this? So if you have other properties, you can access them using this. So look at,
sir,
yes.
so that means if we are to like initiate this this method, or let me say this class, we need to like start from defining the functions, coming down to this place, and then coming down to the instance, and then also as assessing the attributes.
Yes, so when you want to create a class, what you just need to do is to know, first of all, is you have to know the kind of class you have. Maybe you can have many classes. Maybe there are things that are shared with the other class. Maybe you are creating a student class. So when you are creating a student class, you know that there are different kind of student maybe in school. There are postgraduate student, there are undergraduate, there are graduate students, there are undergrad student. Yes? So you have to know in advance. So in that case, you can have these classes, maybe the graduate class and the undergraduate class, they have something in common. Yes? Since they have something in common, maybe you can create a base class, a parent class that contains the general information that belongs to other classes, like graduates and undergraduates. For example, when we create a class called student, this class student can have properties such as, let's say, name, can have first name. So every student has first name. So you can create this class with first name, then maybe last name, maybe other names, age, all this, every student has this class. Then you go to the next class. So you can consider maybe undergraduate student to maybe possess some specialized properties. So you can just write those properties for that class. Then maybe postgraduate has some properties that is peculiar to him. Then from there, you will know how to maybe inherit some properties from this class to this class. So this is maybe class on its own when writing OO design. So you need to learn OO design. So this one, we are just given the basic, but if you want to need more about that, maybe you can go to class diagram, or you can read about UML, Unified Modeling Language, and many others. So to write your class effectively, you need to learn those things, especially if you want to learn. But there are some basic, maybe some things that are not that complex, just like maybe you want to create a cycle class. So when you want to create cycle class, so from this cycle class, you can create as many cycles as you want. For example, some cycles, one cycle may have this kind of radius. All cycles have radius, they have area, they have perimeter. So you can create maybe just like this one, just like this one. So look at this one. So we have the radius. So every cycle has radius. Then you can define, by default, you can define the phi, for example, here. So the user doesn't need to define phi, because whenever we want to get an area, define, maybe we want to compute an area of a cycle, we need phi. Maybe when we need to know the perimeter of the cycle, we need phi as well. So you can define phi here so that the user doesn't need to provide phi here. So this is very, very simple if you know how to deal with it. It's so simple. It makes programming simpler. So that
Hello,
is,
sir.
yes.
Sir, in this initial function, is it every time we must to supply this self attribute?
Yes, that's the convention. Whenever you want to access any value here that belongs to this class, so you need self. For example, here, when you try to print the name here without using the self, you will get an error.
Okay.
Some of you are not familiar with OOP, that's why. But those that are familiar with OOP, they know about this keyword that we use to access values. This dot the properties. So this is how we access values in other. So you will learn a lot. If you have some confusion, you will learn as we go. So here we are creating our first instance. So you can create as many instances as you can. If you want, you can create maybe others here. So we can call this one, can put 1_1, put _2 here. Yeah, we can put _3. Yeah, you can put _4. Yeah, so here we can change the name. So I'm not going to use the name of the person because someone will say that I call his father dog. So Rambar, I'm just using Wonder dialect. So they can have different ages. This one, his age is 4. This one is 7. This one is 6. So here we are creating like 5 instances of this class. So all of this, they share the same properties as this one. So this one has name and has age. This one has name, has age, and they inherit all the function from that class. So this is object-oriented programming. So it makes life easier. You see, we just create a single class, and then we just call the class, and we create our objects here. So it makes life easier. We can create as millions of objects if we want using just this. We just need to give the class name here, then we open bracket and supply the name and age. So we have like 5 instances. So we create 5 instances here. So to know the type, this is what we do. So when we use this type, we know the kind of class that variable is. So here we were discussing about accessing. So if we want to access the name of this instance, we can do this. So if you want to take the name of this one, we just use this. So we know it's gamer. The third one, the name is this. So they have this property name. Every instance of the class has a property called name, has the property called age, and has some functions like sit and roll over. So calling a method, because the class has method, So we can call the method the same way as we call the properties or attributes. So what you just need to do is to give the name of the instance of that class, then you use dot, then you access the method that you want to access. So this is how it works. So here we create the object of this class, then here we call the function in that class. So when we call the function and run, this is what we have. So remember, this function sit, what it does, it will just print the name of the dog, then it will just write this is sitting. So if the name of your dog is Bale, so Bale is sitting. This function, when you call it, it will just print Bale is sitting. When you call this rollover, it will just print the name of your dog, then it will just write this word roll over. So if the name of your dog is Bale, it will just write Bale rolled over. So it's as simple as ABC. When you want to call your function, you just need to provide the name of the object followed by the dot operator, then you write the function you want to access. Simple, yes? So look at this one. So here, the something, get an object, then here we have called the properties here. So when we do this, so this is what we have. So here we are accessing the properties of this object. Here we are accessing another properties called age of this object. So calling method, the something, you just write the object name followed by dot operator, then the name of the function we want to access. So you can access any method here. You can start with this one, then this one. So it doesn't need to be this one, then this one. Then can we create multiple instances? Yes, we could. That's why we create multiple instances here above. So we create multiple instances. That's one of the advantages of using OOP. So we can create as many objects as we can, just as the example we gave the top here. The dog example we gave, whereby we have that template. So to create multiple instances, you just provide the name of the object you want to create. Here you have it, then you call the class name with the values that you want. So let's run this. So this is it. So here we create the first instance. Here is the second instance. Here we are accessing the property name of the first instance. Here we are accessing the property age of the first instance as well. Then here we call my dog dot sit. So here we are accessing the function. We say that the object inherits all the function in the class dog. So here we are calling the function sit. So when we call the function sit, now this is what will be printed because the function sit already has access to the variable call name. So the same thing applies to this. So here we are accessing the attributes for property name, age, then here we are calling the function because they share the same properties of the class. So working with classes and instances. So let's go back to our car class. Here we are creating another class called car. So the car class has 3 different parameters. We have make, then we have the model, then we have the year. So by default, when you want to create an instance of this class, so you need to provide this information. Then here we have another method called get descriptive name. What it does is it gives a neatly formatted descriptive name. So it will just format the name that we call the function with, then then it will just return it. It is not going to print it, it will just return it. So when we run this, and here we are creating our first instance of this class, then we need to provide the name of the make, then the model of the car, then the year of the car. So when we do this, so this information will be supplied to this and will be assigned to these variables. Then here we are accessing the variables here. So when we run this, this is what we have. So you see the name has been formatted. Initially, we give this ID with a lowercase. All these text are in lowercase. This one also in lowercase. Then, but the function here, title, formatted our text. You see this one makes this one caps, this one caps as well. So can we set a default value for an attribute? So this is what we do. So here we have this, here we have this, here we have this. So here is a default. So any object we create or any instance we create of this class will have all the four, but this one is made default. So by default, any object we create, we have odometer reading as 0. And here we have this function that we have already defined. Then we have another additional function called read odometer. And the function, what it does is it will just print this statement. This car has the odometer reading miles on it. So it will just read the odometer. So when we run this, so this is what happens. So here we are creating an object or an instance of the class. Then we provide this, the same information as we provided in the previous example. Then here we get the descriptive name. So we get the same information as before. That's why we have this. It will just format the information we have. Then here we are creating an additional function that we have already defined here, read odometer. So what it will just do, it will just give the reading, because by default the reading is 0. So it will just write 0 here because there is no thing that changed. So can we modify the attributes? Imagine you are creating an account. You create maybe a program that create accounts in a particular bank. So definitely you will have initial balance. So some you know that when you are dealing with banks, your balance changes. Yes, you can subtract or add money. So when you add money, then your balance will increase, and when you withdraw money, then your balance will decrease. So in the case of odometer, we know that it will just keep increasing. It will not decrease. So you can modify attributes just like this odometer reading. We can just modify it. We can modify any of this. So how do we modify it? So we know how to access the attribute. Yes, we just use the instance name followed by the dot operator followed by the attribute name, just like name. So here we are creating here we are accessing this function read odometer. So when we read it, we will see the initial value. Then here we are trying to change that value to assign another value to this attribute odometer. By default it was 0. So now we want to change it, and we know how to access it. So to access it, this is what we have. To overwrite what the values in it, we use assignment operator and use the value that we want to reassign to that attribute. So this is what we do. Then next, here we are calling this function to know what's the current value in this attribute. So let's run and see. So you see, when creating the object here, it has been assigned 0. Then later, we access that attribute and we reassign 23 to it. Then later, we call to confirm whether that value has been changed or not. So it has been changed. So whenever we call this function, we will see it will just print 23 because this is the value we reassigned to it. So this is how we modify attributes. Remember, to access the attribute, you just need to supply the name of the object, then you put dot operator, then you put the property name or attribute name. So modifying an attribute's value through a method. Sometimes you can create a method to modify, to do the job for you instead of just accessing the value directly. So you can just create a method to do that. Especially, it will be better to do that so that no one has access to what you have. This is very important. Sometimes that's why we have these access specifiers or modifiers, so that anyone who tried to even access the value, you will be denied access. You can just you can only modify the value through a function. So let's see that. So here we create another function called update odometer. So all this function has been declared before. We are all familiar with them. So here is the additional function that we create. So what the function does is the function will receive one parameter, mileage. Then that mileage reading will be reassigned to odometer reading. So whenever you are calling this function, you need to supply the mileage, then the mileage will be assigned to odometer reading. So remember, in the same thing here, we create the object of the class or instance of the class. Then here we print the descriptive name. Then here we call the object method instead of just assigning the value by ourselves. Then we call this function and we supply this argument 23 that will be transferred here. Then it will be assigned to this value. So, and here we call read odometer. This function will tell us the current reading of the odometer. So when we run it, this is what we have as expected. The same result as before. Before we got this, and second day we got this. Any questions so far? So here what we do, we extend the method update odometer to do additional work. Every time the odometer reading is modified, let's add a little logic to show to make sure no one tries to roll back the odometer. So because we say that odometer will just keep increasing, will not decrease, we need to provide a logic so that someone will not hack our system. So how do we do that? So here we just write some logic here. So the logic is simple. We already know about if. So what this does, it will just check. So we have, we know the syntax of if. So we have if, then we have test. So this is a logical statement which returns true or false. So this is true or false. So if this condition is true, then it will do this. So what the condition? The condition says that if the mileage value is greater than or equals to odometer reading, then you can assign it. In other words, you can only assign value to this odometer if and only if the mileage value or the value in the mileage is greater than or equals to the current value. So you can't reduce it. You can leave it as it is or you increase it. That's the meaning of this one. So if the value is less, then it will just print this message to you. So let's run this. You see, we know the current value is how much? Is 23, yes? From the previous example, is 23. So when we create another object here, it will just put 0 because we know the default value is 0. So it will be 0 now. Then we update it with 23 here. So when we read, we will definitely see 23. So let's do something. Let me take this one, this part, without recreating the object. So what we are going to do here is, we know that the current value is 23. So what if I try to make it 0? So let's see. Look. So you see, here we are getting the descriptive name, which will print this one. Here we are trying to update with 0 because we know the current value is 23 as we see here. So we try to give 0, which is less than from this logic. So 0, we provided 0. 0 will be here. So is 0, it's just like asking question here. Is 0 greater than or equals to 23? If true, do this. If false, do this. So 0 is not greater than or equals to 23. Therefore, this line will be printed. You can't roll back. That's why we are having this message. You can't roll back an odometer. So the next example, incrementing an attribute's value through a method. So we can increment. You can make increment. Increment means just adding some value, be it 1, be it 2, be it 3. You can increment by 1, you can increment by 2. Just adding value is what is meant by increment. You know, when you go to your calculus, you know that first principle. So here we are incrementing an attribute value through method. Instead of incrementing directly, we can just create increment using method. So look at this additional method we are creating here. So we call it increment. Remember how to name your method. So the name of your method should be meaningful and should map or resonate with what the method does. So the method is going to increment with a given value. So it will just increment odometer reading with the receive value. So this method will receive miles, then it will increment the odometer reading with the miles provided by the caller. So remember this. So this operator has been overloaded here. You can use it, we use it for addition here. So this one can be rewritten as self dot this, then we can repeat self here plus miles here. So we can do this. But some gods, Python provide us with a shortcut. What this means is go and get the current reading, then add miles to it, then the total, store it back to odometer reading. Just like this one. Go and get the current reading, add this value to it, then assign the total to the same variable. So overwrite, just you are overwriting with this and this. We are overwriting the value stored in this with this value. You remember the assignment operator. So when we run this is the result. So here we create the instance of the class with these values. Then here we print the descriptive name. Then here we call the update method. So this is one way of writing numbers instead of putting comma. So you can do this in Python if you have like this value. So like this one. So what you just need to do, for readability purpose, you are allowed to use this, and this. So we have like a million, billion, trillion. So we have trillion and something. So this is the output we have. Then this reads the function, read odometer. It will tell us the reading of the odometer. This one will just increment by 100. Then this one will read, I would call this function read odometer again to see whether the function does its job. So look at the reading here. The reading here is 23,500 miles on it. Then later we increase the mile using this function to increment the odometer by 100. So when you add 100 to this, we have 23,700. Then let's quickly go to inheritance. So inheritance, what it does, let's see this example first. So when we look at this example, we can say that student is a person, yes? Professor is also a person, which means all these persons have name. Student has name and has phone number, has email as well. While this one also has, the professor has name. He has phone number, he has email. So we can have a base class that contains general information possessed by the child class. I will talk about what we mean by child class. So this class contains general information. Like this one is an attribute. All of these are attributes or properties. Then this one is a function. So which means student purchase parking fast. So for a student to be allowed to park, he must or she must purchase parking pass. Professor as well must purchase parking pass. So since they share this information, then we create a class called parent class. Parent class. Then this student number is peculiar to student. That's why we have it here in the child class. And average mark is peculiar to student, while the professor has staff number instead of having student number. Then he has salary as well, but the student doesn't have salary. Then there are years of service. There are a number of classes that the professor teaches. Then there are no functions for this one. While this one has some function, maybe is eligible to enroll, get seminar taken. So this one is Boolean. Then this one is not. So you just provide information about the number of seminars taken. So this is the design. When designing this kind of parent-child relationship, what we do is we look at the class as a whole. Can we have a subclass out of that class? So if we can, we create another class based on that. If you are familiar with entities when creating when modeling database, you know that when you have entity, sometimes you can have another entity. So you can create another entity based on that entity you have. So the same thing applies to this one. So you don't always need to start from scratch. When you have a base class, you can inherit something from it so that you can use it, you can add your additional things. Those who are familiar with Java or writing maybe mobile application know about this. They know how to inherit many things. If you write Android, you know how you inherit many things. So if the class you are writing is a specialized version of another class, so you wrote so you can use inheritance. So look at this one. This one is a specialized version of person, because we know that student is a person. And professor is also a person, which means this one is a specialized version of person. So professor is a person, but specialized person, while student is also a person, but specialized person. It has peculiarities. So in that case, you create a base class, then you can inherit things from this class. So let's look at the car class we just created. So look at the car class. So this is the car class. We know generally cars have make. Yes, they have make. Those who make the car, then they have the model, then they have the year, then they have odometer reading as well. So all the cars share these properties. All the cars in the world have this kind of attributes. And then they have some functions. Maybe here we are trying to model a class for car. So in Python, this is how we do it. So we should have this kind of function. We have this function as we already defined. We have all these functions, we already defined them. So this is how we model a class. We have the attributes, then we have the functions. So all of the class we are going to create will have this information. We'll have all of these properties. But electric car may have some peculiarities. Yes. So in that case, we inherit some of these properties because we know that this electric car share the same properties with all the cars, but it has some peculiarities. So in that case, we inherit the general information from the base class or super class or parent class. We can call it with all these names depending on the book we are reading. When you read some books, we call it super class. When you read some, call it base class. When you read some, we call it parent class. So this class, the child class that is inheriting information from the base class or parent class or super class, is this one. Is called subclass or derived class or child class. So this is the parent because it is the one who gives, just like your parent. They are the one who gives you food, gives you things, give you milk and whatever, and give you money. So just like that. So we inherit this from our parent. So we have our peculiarities. So when we have, this is what we inherit from the parent class, then we can define our peculiarities here. So if we have functions, we already inherit functions from the base class, then we have our own other specialized functions here. So we can define them here. So this is the example. So look at this example. So I think I have this. So look at this. So we have the class car, then we have this, then we have something. Did I miss something or what?
The comment triple quote is not complete under the car.
This. Okay,
No, the
yes,
one above.
yes, exactly. Yes. So this is it. Sure. So this is it. Thank you for your contribution. So here we have this class, then we have this function that we have already defined, then we have all this, we have this as well, we have this as well, and we have this as well. So in the same class as defined before. So when we do this, so we have the class here. So what we are going to do, because we have specialized car, which is electric car, then we inherit all of this, including this method, this method, this method, and all the other methods from the class car, then we can have our own. So before having our own, look at this. To inherit a class, this is what we do. We write the class, our new class, our child class, then we write the name of the class. Then we write the name of the class we are inheriting from. So we are inheriting from car class. That's why we have car here. If you have additional classes that you want to inherit, you can just put comma and put all of the other classes. Then look at our init method here. So we have our own init method, which when creating the instance of this class, we need to provide this basic information. So when we provide this, instead of defining all of the other functions that we define in car class, we can inherit all those functions by just writing this line. It's as simple as writing this. You call this function SUFA, then you use dot, then you use init. So here you are calling the init function of this class. So remember, when you call the init function of this class, this is what it does. It will just assign this to this, assign this, and this provide default value for odometer. Then here we are creating an instance of this class, and we provide this information. But look at this line. This line is using this instance to call this method, and we didn't define the method here. So because the method has been inherited from the parent class, then we can call it here. So when we run this code, look at what we have. You see we have this. We provide this Nissan, all in lowercase, leave all in lowercase, and this year, and you see that our information has been formatted. So we inherit from this class. So I think that's all for today. If you have questions, and you can raise your concern, you can ask question if you have. If you don't, we are already 48 minutes after on top of the hour. So let's see the okay, now let's call it a day. Thank you for listening. So see you. I think we have a holiday next week. So see you after the holiday.